Hello, I'm Richard with EV4U Custom Conversions, and welcome to another episode on our Karmann Ghia, where we're upgrading it from DC to AC. And so I think the last time we left off, we had just removed all the components and had taken a look inside the controller. Well, where we're going to start off now is we need to decide the placement of all of our new components. Well, the motor is a pretty easy one. That's going to go, attach the transaxle. No decision there. But this is our component board, and we're going to reuse this one. We just need to decide placement of a few of the components. We're leaving the shunt in place where it was before because our negative line coming from the battery pack and everything was designed to make this distance, so we'll leave that. Won't be in the way for anything else. Our throttle is going to go back where it was before. We can keep our same alignment and everything there. But what's going to be new is the Curtis 1239 controller. And this, of course, has a different footprint than the Magnetics had. And so we're going to have to decide just exactly where that will fit, where we'll have our clearances, where it doesn't interfere with our mounting points and so forth. So it's a little heavy and awkward. So to lay that out, we're going to use the chill plate that fits right underneath this. It's the exact same profile as the base of the controller. And so in order to have our water cavity, its highest point has to be lower than our reservoir. So we know we need to keep this down kind of low. We need to miss our mounting points and so forth. And so it looks like we're going to put it right about here. And let me just set this on top for a moment. So this is how we'll look. The throttle will be here. We'll have to route our cables. Negative will go over here to the shunt, and then the positive is going to go to our contactor. Unlike the Magnetics, and just like the air-cooled Curtis, they use an external contactor. So we're going to mount the contactor in such a location, mounted on our board right here, that we can make a nice connection here between the contactor and the positive. And so exactly where that's going to be at the moment, haven't decided. So kind of scope that out. It'll be in this neck of the woods. And then this is our relay, our pre-charge relay, and our pre-charge resistor. And we're going to mount those on the sideboard that goes over here, like yay. And this has had quite a few different components on it. You can see it's starting to look like Swiss cheese because this car has been a test bed, and we've had multiple different components and wiring setups. So what we're doing is we're going to go completely back to square one and cut out a new one. Make it easy, we'll just trace this one onto here. And because this will be starting over, we're going to have very little on this. We're going to have a couple terminal strips and our pre-charge relay And I think that's going to be about it. It'll be pretty clean. So that's that. As far as the wiring goes, the car's been converted previously, so we have all of our wires running from front to rear and so forth. We even have extras so that when we have modified things, we don't have to rewire anything. Well, in this case, we are going to have to run one additional wire, or a set of wires that are in the same little loom, and that is the Curtis display, the Curtis 840 display, which will be in the dash. That runs from the controller plug, that harness, and that needs to come forward. Beyond that, all the wiring will be done in the back here, short runs, basically between our terminal strips. And so this terminal strip, this was an existing one. It'll go back in the same place. We'll add the other one above it here, and then add the relay. This has all the wires that go front to rear, and so we have 8 of them that go from front of the car to the rear of the car. Those will all be addressed on this terminal strip, and then components and so forth, wiring, all that's here will be on the other terminal strip. And we're going to have 3 or 4 extra connections, which will be nice. Okay, so let's take a quick look at the Curtis display in the dash. We had a display in there that was from the original conversion of this car, which those of you who follow this channel realize or remember that we did in 8 days, and it originally featured a battery monitoring system and had a display that showed you all the individual cell information, blah blah blah. You know, that you look at that a few times and it just not real valuable information, since the cells in 3 years haven't changed one iota. So let's take a look at the dash and see what we did there. All right. So what we have in here is the JLD 404, which is been in here a long time, and then this is the Curtis 840 display, which will give us RPMs, controller temperature, motor temperature, other information. Mostly we're going to use it for the RPMs and the temperature monitoring, and then the rest of the gauges that have been here all along. Now, to be able to cycle through the settings on the Curtis, they normally use a little red button. You saw it on other conversions that we've featured in videos, little menu switch. Well, we already had a momentary switch right here, and so we're going to use that as our menu switch, so no changes there. Quick shot at the back, all taken apart and ready to receive the new components. Okay, so I've mounted the components on our board, and also made a new side panel with our 2 terminal strips and our pre-charge relay. Now, this hole right here is where all the wires come through that all go from front to rear. They all attach right here. Allows us to remove this from the car in one piece if we wanted to. So anyway, there's 4 wires that then connect this side panel to this. Main component board here is basically assembled and ready to be installed in the vehicle. But I can't put it in the vise right now because of the way things are in here. So it's laying down flat. We'll grab the camera and give you a little better view. But what I wanted to say about this is I do it this way because I feel it's easier to assemble and do this on the workbench than it is in the vehicle. And so we do as much as we can, and then we'll bolt it in the vehicle. So let's take a little closer look at what we've done here. So what we have is our chill plate right here, the base. This darker area is the chill plate. And we have our coolant in and our coolant out. This is just a port that is tapped for a temperature sensor, which we're not going to be using. We're going to monitor the temperature of the controller itself. And then we have our throttle right here. Just the arm isn't on right now, but here's the electronic throttle. We have, if I can move this a little bit. We have our shunt, and we have our main contactor. Off the main contactor we have 2 wires that will go, and then they go to the pre-charge resistor. It's on the back side of this. So anyway, we'll bolt this in the vehicle, and then start to wire it up. And we'll show you a little bit about that. It's all very simple. We're just going to follow a schematic, and this is provided by High Performance Electric Vehicle Systems. Very easy to follow. Comes with a nice wiring harness. We made up a legend for our terminal strips. I'll clean that up later on, but that's my initial copy. And you can see we basically did all the wiring that we could do with it out of the vehicle. So, let's go put it in the vehicle. So we have the component board set in place. I just started the bolts. We'll start to snug these up. Used to be 5 bolts that held this in place. We only have 4. But I'm sure that's going to be more than enough because this board doesn't weigh that much. It's mounted on standoffs, so it's actually away from the firewall. And this is molded in place. So, the 2 lines that will connect our cooling system to our controller are right here. This is the in. This is the return. We've got the throttle here, which will hook up. We have the 4 wires that will connect to the side panel on the left, as well as the throttle connections, and then the other connections here. These 8 wires, our charger, and our 2 power lines. The rest of it is going to be hooked up to the wiring harness that goes to the Curtis controller. And so that's what we're going to basically do next before we mount the side panel in place with it loose, so we can get to the back and route wires and everything. We'll do all that. It's going to come out of the panel here, drop down, go behind, and up and around. That way it stays away from the clutch and the throttle lines and so forth. The only thing we have to dodge here are the coolant lines, which they basically are here over. Then the motor will be right here, and as soon as we get this wired up, we'll install the adapter, coupler, the clutch, and mount it in the car. So it's really easy thing to do. You just do it one step at a time, very systematically. And so like I said, we're going to hook up a few things that were disconnected when we took the component board out. We'll do that first, and then we'll start wiring the Curtis harness. So stay with us. Well, here's the harness for the Curtis controller. Here's the main plug. So we don't use all these wires. We've never used all of them on any conversion. But typically the classics, we keep them fairly simple. Just depends on what the customer wants. In this case, this is the vehicle that I drive every day, and we're going to keep it kind of the way it's always been, and that's just pretty much cut and dry and very simplistic. That will now feature regenerative braking, which it didn't have before, but at the cost of a little bit of performance from what I've been used to. I'm not going to have quite the torque and acceleration, but we're going to have a motor that runs cooler, hopefully a controller that runs cooler. We're going to be monitoring the temperature on both as we're going down the road, and so we'll see how this system works compared to the ones that we've run in the past. Our only issue has been temperature, and that's because, like I've said so many times, that we're running 75 miles an hour in hilly terrain in 100+ degree temperatures, and we do that for months during the summer. So it's not an occasional thing, it's a daily thing. So this is all pretty straightforward. Most of the wires that we're going to use on this, I should say all the wires that we're going to use on this, with the exception of this one, will all be short runs to our terminal strips right there. This goes to the Curtis 840 display, which is in the dash. This is the only wire that we're going to have to run all the way up the vehicle. And so we already have a hole with grommet and everything in the vehicle, so we don't have to do any of that. I did have to remove the kick plate, and we'll have to peel back the carpet and that type of thing to run it forward. But hopefully should be no big deal. The length can be a problem, but on this route it shouldn't be. And so we're going to go ahead and plug this in, so we have a fixed point here, starting point, and then we'll route it forward, see what happens. And then like I said, we'll start using the schematic and routing the wires, and I'll show you a little bit what I'm talking about, and you'll have an idea. It's actually quite simple, and we'll do a couple of them step by step. Okay, we're going to talk about the wiring. Now, this is a 35 pin connector, it looks like, and they don't use all of the pins. There's 2, 4 that looks like they're not used. So maybe 31. And not all those are external connections. Some of those are, like goes to the encoder on the motor, and it goes to the display, so forth. So not all those are external connections. But out of the connections that are on here, we're going to make 10. And we'll talk about those real quick, and we'll talk about a few of the ones that we're not going to use. We're going to use this KSI. That's one that everybody would use. That's the 12 volt into the controller, basically turns on the controller. You've got a tachometer driver. We're just going to use the tach and the display since it's right there, easy to see in this particular vehicle, and it doesn't have a tach in it from the factory. You have a brake light switch. We're not going to be using that either, because we're not going to use that aggressive of regen. What that's for is so that when you let off the throttle and it goes into regen, that you could have the brake light come on. A lot of your factory cars do that. I don't like that aggressive of regen, and so not going to use that. Pre-charge, we're using that. Clutch shift switch, not going to use that. Main contactor coil, we're using that. Ground, we're using. Pedal interlock, things like that. Those are used on like the Curtis throttle where you have the little micro switch. We don't have that on this electronic throttle, so that's not used. Menu button, we're using that. Start button, that's typically used on vehicles where you have an idle. You're using the idle circuitry on this. I'm not going to be using that. Economy mode, I don't bother with that. I don't drive that economical. I just drive the way I drive. But you could, use that, have a switch, and you have normal or economy, however you want to look at it, and program in economy mode, which just reduces the amount of power to the vehicle or to the motor. Coil return, we're using that. Brake switch input. We don't use regen with the brakes, only with the throttle. We're just going to replicate the way that a internal combustion engine felt in this vehicle. Beyond that, we're not going to go any more aggressive, but you could use it to where, when you put on the brakes, it gives you a whole nother set of parameters that you can use for regen. You can use a brake transducer, so forth. Then there's pot high. We're not using it with this throttle control. Pot wiper, we're using that. You got your can. We're not using that. forward, we're using that. You can actually electronically switch this motor forward and reverse. We've got a gearbox, so we don't need that, but you still need to hook up the forward. I've had people call me and, thing wasn't working. Well, they forgot to hook up the white forward wire because, I thought, well, I'm not using forward and reverse. But you need to have that connected. 12-volt control. That is used. That's what is the other half of like your menu switch and your forward and so forth. That's the 12-volt power for all those circuits. And 5-volt, we're going to use that because that's what's used with our particular throttle. And the rest of these, the encoder and so forth, that's already a plug. So we're only going to use 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can see that, that's not a lot to wire up, and we're going a very short distance. It's not a big deal. So what we are going to do is we're going to separate the wires that we're going to use from those that we're not going to use, and we'll just separate those out. The others will be rolled up, wire tied, and put out of the way, and the others will be routed around to our terminal strips and the connections made. And it's just a matter of routing it, coming through our holes, crimping a terminal ring on there. We're done. The one that's going to take a little bit of time is this one. Like I said, this is for the instrument, or the display. And so we're going to route that with the rest of our wiring to the front of the vehicle. Nice thing about this particular project is that it was done previously, as far as it's been converted in the past, and so we didn't have to run everything. We didn't have to, put in the battery pack and all that stuff. That's already in place. And what we typically do, and you can see it here if I drop this down, is we'll use trailer wire. This is just a 4-conductor, 14-gauge trailer wire for wiring trailers. And so, depending on the vehicle and how many circuits and so forth we're running from one end to the other, on this one we just ran 2 of those. And so we have 8 wires that go from front to rear. The only other one that goes all the way to the front is the charger. We're picking up the negative side of the charger, comes off our shunt here, so that when we're charging the vehicle, that current goes through the shunt, and we measure not only what goes out of the pack, but what we put into the pack. And then the high voltage wires, they only go to the other side of the firewall here, and a short ways beyond that to our traction pack, which is just behind the seats. So this is a nice setup to do. They're short runs. We mainly do Porsches, and they have split packs in the back, and then they have a pack in the front, and so there's a little more wiring and stuff when you do that. Here's another one that's segregated out right now. We just have it sitting over here. This going to go a short run. This is the encoder. This is the communications between the motor and the controller. So that's what I'm going to do next, is segregate out the wires that we're going to use and the ones that we're not going to use, and then I'll run this wire forward. And once I've done that and am doing this, we might cut back and show you a little bit, you know, how we're wiring this up. Don't go away. Okay, if you can see here, this on the left is what we're not using. All this on the right is what we are using. And so really, let's see, how many are we not? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, plus the can. So it looks like we're, you know, using about half of the wires will be used in this conversion, and the rest are not. And it looks like they give you about 12 feet of wire. And so we'll roll that up that's not used and wire tie it, tuck it away where it won't get damaged. So we'll do that, and like I said, then we'll run the line up to the display in the dash. Well, here's a quick shot of the component board and our side panels just about in place. Still need to bolt in the coolant reservoir side. This side is in place now. Side panels back in. We're wired up. Throttle's reconnected. Secondary return spring. So what's left is to install the motor and wire it up, which is very simple. We're going to take this plug right here, which will connect to the encoder on the motor, and then our 3 phases right here. And that's simple, simply just connecting V to V and so forth. And it's very, very simple. Like I said before, you just do it a step at a time, very systematically. So let's move over to the workbench and take a look at what we're doing with the motor now. Well, here's the motor. You've seen the controller, the Curtis 1239. It's a 500 amp and it's good up to 170 volts. We're running 146. And this is the motor that High Performance Electric Vehicle Systems mates with that. This is the AC51. And so, what we're going to do now is install the coupler. This is a one-piece coupler. It's made by Canadian Electric Vehicles. You can see where we do a video on their adapter coupler setup. This is kind of a hybrid here. This is their coupler, but we're using a billet aluminum adapter instead of Canadian Electric Vehicles cast aluminum adapter. I like these better for several reasons, but no one will argue that aesthetically these are a better looking adapter. So that will then be bolted in place here, and then this will bolt to the transaxle just like the stock engine did. But before we put that on, just for ease, although you could do it either way with this design, but I like to just put the coupler on first. And this is a slight interference fit. So what we're going to do is we're going to take a heat gun, heat this baby up. And that's why I was wearing the gloves. and then we're going to slide this on, and it bottoms out against this base on the shaft here. So anyway, you can tell when it's on all the way, it'll clunk and stop, and so you want it all the way on. And then some Loctite and 3 set screws. The coupler's done. Some Loctite and 4 bolts here. This baby's done. So, not going to bore you with all of that. We've got lots of other videos that walk through this part of the process of installing the flywheel, the clutch, so forth. So if you're interested in that, you can visit our website at EV for You Now, and there's a listing of YouTube videos on one of the pages. You'll see it on the home page, or it'll say listing of YouTube videos, and go to that and it will take you to the appropriate video. So we'll meet you back here after we have this all put together. Here's a quick shot of what it looks like with the coupler and adapter in place. Motor with the clutch and flywheel installed just before we lift it off the workbench. Okay, here's the motor installed and wired. So before we can test things, we have a few things to do. I'm going to fill the cooling system with coolant, 50-50 mix. We'll test things and then we'll put the bottom cover on the motor and a few things like that. A few of the cosmetic things that need to be done. We're going to attach the wire here, so forth. So, you know, there's some detail work to be done, but we're at the point now where we'll fill the cooling system just so it doesn't get, we can turn it off. It's off right now. We have a switch back here that allows us to turn off the cooling system so that we can hear things and not have that noise if we're doing, you know, troubleshooting or whatever. We just added that switch. So we don't have to have it on, but it's nice to do it and get it out of the way so you don't forget. If you run these pumps dry, they're toast. So we'll take care of that while it's still forefront in our minds, and that way we don't forget it. And then we'll go through the test sequence, make sure everything works. First thing we'll have to do is set the throttle type, make sure that's programmed, and then we'll, after we confirm that everything's working as it should, then we'll go through and do the fine-tuning. Just thought I'd give you a quick look at what the final layout looks like. And so anyway, not quite as sharp looking as it was with that net gain Impulse 9 motor and the Garrett supercharger mounted on it. That was a real eye catcher, was always a real conversation piece. So we're going with less fluff and hopefully more longevity, going with the cooler running AC setup. Well, after driving it around for several days, I gotta say it runs like $1 million. The real test will be once it's, you know, 100 degrees out again. We'll see how it does, you know, under the extreme temperatures that we've always had an issue with. But for now, winter's setting in, and so we'll just get used to the new feel of driving the Karmann Ghia with regenerative braking. And we look forward to bringing you some new projects. But what started all this YouTube channel for us was response to your questions. So if you have any questions about converting a vehicle from gas to electric, shoot us an email at info@ev4unow.com, and we'll answer your question. And if it's a question that we think has a wide appeal, we'll try to make a video and address the question and post it for everyone. So once again, we thank you for watching. If you like our videos and the information that we present, subscribe to us, and we hope to see you again soon.